Today, we will be talking about IP addresses, domains, and URLs. Every device on the internet has a unique IP address, like its digital home address. But since numbers are hard to remember, we use domain names like google.com as easy to read labels for those addresses. URL goes on step further by giving the full web address, including the protocol, domain name, and the exact location of the page or file you want to access. The original Internet Protocol, let's start by discussing IPv4. The original version of the Internet Protocol, IPv4, uses 32-bit addresses, which means it can support around 4 billion unique IP address. At the time of its inception, this number seems more than adequate for the number of devices that would connect to the internet. However, with the explosive growth of the internet enabled devices such as smartphones, computers, IoT device, and more, these 4 billion addresses have proven to be insufficient. Today, the pool of available IPv4 addresses is essentially exhausted, leading to the need for a more robust solution. So, to address the limitation of IPv4, we now have IPv6. The next generation of the Internet Protocol, IPv6, uses 128-bit addresses, vastly increasing the number of possible IP addresses. In fact, IPv4 can support 2 to the power of 128 addresses, which translates to about 3.4 into 10 to the power of 38, or 340 undecillion addresses. This enormous number should be more than enough to accommodate the needs of the internet connected devices far into the future. Although IPv6 provides a much larger address space, IPv4 and IPv6 are currently coexisting. The transition to IPv6 is ongoing and will continue over many years, ensuring that all systems can gradually adapt the new protocol. So let's start with the concept of domain names. Domain name is a user-friendly representation of an IP address, making it easier to navigate the internet. For example, instead of remembering the IP address, for example, a number 198.35.26.96, we can simply type just wikipedia.org. This is much easier to remember and type. Domain names are case insensitive, meaning if we use all caps Wikipedia, it's going to be the same location as all lower letter Wikipedia. So why use domain names? Because they are hard to remember. The IP addresses are hard to remember, and the IP addresses can change while the domain names are always a constant. So now let's talk about the domain name system or DNS. DNS is essential for translating these human readable domain names into IP addresses that computers use to communicate. When you type a domain name into your browser, the first step contacting a DNS server to find out the corresponding IP address. There are 13 main DNS root servers distributed around the world which provide the critical services. For example, IP address like 198.41.0.4 run by VeriSign or 192.203.230.10 run by NASA are part of these root servers. Next, let's discuss how domain names are registered. To claim an unused domain name, individuals or organizations can register it with a domain name register. Registers typically charge a yearly fee to maintain the registration of the domain name. This ensures that the domain remains associated with the registrant. The details of this registration are managed by ICANN's WISE service, which keeps a public record of registration information. When a website is hosted by a web hosting company, the company will handle the DNS setting to associate the website's domain name with its IP address. This way, when someone types in the domain name, they are directed to the corrected website. And additionally, many hosting companies offer services to manage the yearly registration of the domain name, making the process hassle free for website owners. Finally, let's talk about the structure of domain names. Domain names are hierarchical with different levels. At the top are the top level domains or TLDs. TLDs such as .com, .net, .gov, .org, etc. Each country also has a unique country code TLD. For example, for United Kingdom, it's .uk. For Russia, it's .ru. .de for Germany. Recently, customized TLDs have also become popular, allowing for more options like .charge, .pizza, .music, etc. The TLD we have um, is the second level domains. These usually represent the name of the organization or purpose of the website. For instance, in wikipedia.org, Wikipedia is the second level domain. In stanford.edu, Stanford represents the university. Moving deeper, we find third level domains and beyond. These often refer to specific subdomains or subsystems within an organization. For example, um, cs.stanford.edu. So, CS standard for Computer Science Department of Stanford. A commonly used third level domain is www. Standing for World Wide Web, which typically refers to an organization's main web server, as seen in www.stanford.edu. Many organizations allow visitors to omit the www, automatically directing them to the same place. Now let's start by talking about URLs, which stand for Uniform Resource Locator. A URL is essentially the address of a web resource on the internet. For instance, the URL http www.cdc.gov/alcohol/fags.html points to a specific web page hosted by the CDC. Web resources can include various items such as HTML files, images, videos, CSS style sheets, etc. Now let's break down the different parts of a URL. First is the scheme. It defines the protocol being used to access the resource. Common schemes include HTTP, HTTPS, mail to, and file. For example, in HTTPS :/www.cdc.gov/alcohol, the scheme is HTTPS. Then the host name, this is the complete domain name that follows the scheme. It tells us which servers to connect. In our example, the host name is www.cdc.gov. Now, path, the path specifies the exact location of the resource on the server. In HTTPS :/www.cdc.gov/alcohol, the path is /alcohol. Now, query setting, this is optional and appears after a question mark. It provides additional data to the web server. For example, in the URL https //www.youtube.com/watch, and then the question mark, and then the tag v equals UU7XCE That's a very cumbersome arrangement of letters or numbers. So it tells that which uh, YouTube video to play. Now the fragment, it's also optional. It follows a hash character and refers to a specific section within a web page. For example, after the link slash history, the fragment slash history directs the browser to the history section of the page. Moving on to common web page errors, there are several types of issues users might encounter when browsing the web. First, the DNS errors. These occur when the DNS server cannot find the domain name. This usually happens because the domain name is not registered. When this happens, users might see a message like, sorry, the website blah 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 cannot be found. Server non-response. In some cases, the domain name is found, meaning a valid IP address exists, but the web server does not respond. This could be due to the server being turned off, undergoing maintenance, or due to network issues, for example, malfunctioning router. In such cases, you might see error message like the website is not responding or could not reach the website. Now, finally, the 404 error that we find it very often, and this is a specific error that occurs when the web server is reachable. But the requested page does not exist. This might happen if the page has been removed or the URL is incorrect. The server returns a 404 status code, and users often see a message that includes 404 page not found. That's all for this lecture. Thank you, everyone.